So welcome to this segment as we try to look at continue with our 2022 chemistry paper 2 revision B4. Salts are important substances that have many uses. A. Describe how a fairly dry sample of lead 2 sulfate can be prepared from aqueous sodium sulfate and a soluble compound of lead in the laboratory. So now you're preparing, lead 2 sulfate, which is an insoluble salt. So you need two soluble salts. One of them, they have already told you, is actually sodium sulfate. Another soluble compound containing lead is nitrate, lead 2 nitrate. Remember, all nitrates are soluble. So you want to pick up, lead 2 nitrate there. So they want you to see how you can do that. So the first thing that I can do, you can simply say maybe, prepare an aqueous solution of, I'll be using the symbols of sodium sulfate and, lead 2 nitrate in separate beakers. So you can actually prepare them in separate beakers. Then next, mix the two soluble compounds. Then an insoluble compound forms, which is actually lead 2 sulfate. So that lead 2 sulfate is going to form. Then filter the resulting mixture and get the residue. So the residue in this case will be lead sulfate because it is actually insoluble. It does not dissolve, so it will remain on the filter paper. Then we can say wash the residue with distilled water and dry between filter papers, in the sun, or if you want you can use an oven or use a desiccator. The space was too little that they actually gave, but this is what you can basically do. Then it says suggest the name of another salt that can be prepared in the same way as lead 2 sulfate. Remember, like I said, lead 2 sulfate is actually an insoluble salt. So which other insoluble salt are you thinking of? You can also prepare barium sulfate in a similar way. So barium sulfate can be prepared. You can also prepare what we are calling as being silver chloride in the same way. So silver chloride can also be prepared in the same way, and many others that you can actually get to study about. Let's come to B5. It says calcium nitrate decomposes on heating according to the equation. So when heated, that's a symbol for heat. It breaks down into calcium oxide. Then that's nitrogen dioxide and oxygen. Copy the equation given and balance it. So we need to copy it. So we have calcium nitrate. When subjected to heat, it changes into calcium oxide, produces calcium oxide, nitrogen dioxide, and oxygen. Now, of course, balancing is a trial and error. So what you can do there, you can put up a 4 here. When you put up a 4 here, it simply means you have got 4 nitrogen. You put up a 2 there, you're going to have 2 calcium this side, put up a 2 there, then I think this equation will be balanced. Let's check it out. There's 2 calcium, even this side 2 calcium. Nitrogen, 2 times 2, that's 4. 4 by 1 will give me 4 there, 4 nitrogen. What about oxygen? Let's start with the right hand side. 4 times 2, That's basically 8. 8 plus 2 here, that's 10. 10 plus this 2 here, that's 12. So it will be 2 times 2, 4. 4 times 3 is also 12, meaning the equation is balanced. So you needed just to put a 2 there, a 2 there, and also a 4 there, then it is balanced. Then B says calculate the relative formula mass or the mixture of calcium nitrate. Now for calcium nitrate, it's for 1 more. When you're finding the mixture, it's for 1 more of that compound. So we are just basically taking calcium nitrate like this. If you are struggling, you can simply further break down this and expand. 2 times N will give you N2. 2 times 3 will give you O6. So if you want, you can do it that way. Then you can identify your oxygen, how many nitrogen, and how many calcium are there. So it will be there 6 atoms of oxygen times the mixture of oxygen, which is 16. That will give us 96. Nitrogen is 2 times 14, which will give us 28. Calcium is 1 times 40, which is going to give us 40. So therefore, what will be the relative formula mass? So we can add 96 plus 28 plus 40, and that is going to give us a 160. That is going to give us a 164. Hopefully we are together. So that is the atomic mass unit, if you want. So that's what the question was saying, and that was just 1 mark. Let's come here to this question. It says 16.4 grams of calcium nitrate is decomposed. Calculate the volume of oxygen gas liberated at room temperature and pressure. So it's at RTP. Now this is very simple. From the balanced chemical equation that we got, let me just write it this side so that you are able to recall it. When it decomposed, it gave us that, and we had 4NO2 plus oxygen. So from there, we are comparing the calcium nitrate and also the gas we are talking about, which is oxygen. Now, we can find the total mass from the balanced chemical equation. What's the total mass? Remember, just the mixture of calcium nitrate was 164. That's what we got in my previous answer here. So you just say 2 multiplied by 164 to know the total mass of this compound. So 2 multiplied by 164, it is giving me basically 328 grams. So the simplest you can do, you can get the total mass of this compound, 328 grams of calcium nitrate, and say this equated to the volume of 1 mole of a gas at RTP. Remember, 1 mole of any gas at RTP, room temperature and pressure, is 24 cubic decimeter. So you equate this total mass from this compound, equate it to 24 cubic decimeter of oxygen. Then just pick up this mass they now used or decomposed and say, what about 16.4 grams of calcium nitrate? Then what volume will that give me? Then cross multiply. So this times that will give us 328x is equal to 16.4 multiplied by 24. To find x, I'll divide 328. What I do this side, I'll also do it the other side. So x will be equal to, if you calculate there, 16.4 multiplied by 24, what we get, we divide by 328 there. It is simply giving me 1.2. So this will give you 1.2 cubic decimeter, that is of O2. So this is the volume that will be occupied when 16.4 grams of calcium is actually, decomposes. So you need to remember that very important, aspect. Let's come to B6 and see how we can do that. The following elements with their electronic configuration are in a certain group of the periodic table. So they have given you this. If you notice in the outermost shell, there's 8, there's 8, there's 8, except this one. This reminds us of the elements found in group O of the periodic table, sometimes called as being group 18. So name the element in which these, name the group in which these elements belong. So it is simply group O, or sometimes as you advance, that is group 18, but group O at your level, that's okay. What accounts for the chemical reactivity of this group of elements? So we can simply say they have, 8, let me say they have got, 8 electrons, they have 8 electrons in their in the outermost shell. Of course, except, maybe, helium, possibly represented by 2 there. But the rest of the elements have actually 8 electrons in their outermost shell. And because of having that, those 8 electrons in the outermost shell, that makes them actually stable. Or if you want, you could have actually said, they have a full valence shell in their outermost shell. Yeah, so if you wanted, you could have said they have, full valence, shell in the, yeah, so they have full valence shell. Probably just ending there is okay. Then you have actually taught them. C, W is used in weather balloons. Explain why W is the most suitable, for this use. Yeah, so that, like I said, could have actually been helium if you go to group 8. So we can simply say they are less denser than air. So they are less denser than air. And another reason, they are unreactive. So those 2 reasons make them to be more suitable. They are less denser than air, then they are non-reactive. So they will not react, and that makes them to be suitable to be used in weather, balloons. D, describe the change in density as you go down the group. You can see what is happening even when you write the electronic configuration. Yeah, so as you go down the group, their densities increases. So as you go down the group, you're going to find that their densities increases. So that's the idea. Please watch out in my next video. We are going to look at now, B7, and I'll show you some other questions so that I can guide you. If you love what we do, please subscribe so that you can learn with Mr. Nyendwa. Thank you so much for watching.